In this video, we'll look at some of the mechanisms in place to support the idea of transaction and identity privacy within the blockchain network. If you recall, we're dealing with permissioned ledger access. In other words, there's a predetermined group of entities that have access to the common ledger. However, you may want to limit access to the details of specific transactions to only those entities that actually participated in those transactions. So in this video, we're going to look at some of the mechanisms in place to support that level of privacy. Let's dig deep into this idea of private transactions by looking at a specific example. In this scenario, we'll look at a transaction that will be recorded in a ledger that involves user A and user B. So these two users from different organizations are about to interact together to create a transaction that will be recorded in the public ledger. But before we get into mechanics of that, let's talk a little bit about certificates. So if you look to the left, you can see our certificate authority and our membership component. So the certificate authority manages two types of certificates. First, they're e-certs or enrollment certificates, which is pretty much what most people think of when they think of certificates. These are relatively long-lasting certificates, so they will expire, but typically, on the order of years or many months in the future. And these will be issued to each participant. So, for example, in our scenario, blockchain user A will have their own e-cert and blockchain user B will have their own e-cert. But there's also another kind of certificate that's managed by the certificate authority, and those are called T-certs or transaction certificates. These are short-lived certificates, which you can think of like credit card numbers that are generated on the fly for a single e-commerce interaction, which allows buyers, online buyers, to operate with a much greater degree of security and privacy because their real credit card numbers are never shared with the merchants. There is one level of indirection where a one-time credit card number is generated for that e-commerce transaction, and that is mapped back to a real credit card number. But again, this is outside the scope of the merchant. So very similarly, these transaction certificates are derived from the enrollment certificates, but having access to a transaction certificate will not allow you to trace it back to its owner unless you are the owner of that particular certificate itself, or you are the certificate authority. With that background in hand, let's look at how this transaction would work. So user A would invoke the smart contract transaction and sign it with their transaction key, and it would also be encrypted with both the transaction keys of user A and user B. So as part of this process, user B would share the T-cert public key with user A so that both keys could be used to encrypt the smart contract transaction. Methodology of allowing multiple parties to encrypt a single document is known as threshold cryptography, and what it means is that up to a threshold number like 4 or 5, which equals the number of participants, you can actually have each participant encrypt a particular document, and the net result of this is that only those participants can decrypt the document. So it's a way of creating privacy beyond just two parties. When we normally think about cryptography, we think about two parties, one that has access to a public key, one that has access to a private key, and they can exchange information. Well, in threshold cryptography, it's the same concept but extended to many different participants. So if we look here, we can see that the smart contract is invoked. It's encrypted with the transaction keys of both user A and user B. So these are the participants in this particular transaction. And then it's recorded in the ledger. And what this means is that even though this particular transaction is in the public ledger, only user A and user B could actually read it or make sense of the data. This is very analogous to the idea of a virtual private network that runs on the public internet. So a VPN sends its data over the public internet, but that data is encrypted and only the participants in the VPN can actually make sense of that data. A malicious third party, for example, intercepting that data flow would not be able to make sense of it because they wouldn't have the keys necessary to decrypt the data. So that's how the transaction is actually recorded in the ledger and made private. A couple other notes. In our diagram, you can see that user B can also invoke applications that can access the ledger directly using their own transaction key. So this gives them access to transactions, for example, that have already been written. So now let's switch gears and talk about the smart contracts. If you recall from earlier videos, smart contracts are stored on the ledger as well. And depending on a particular smart contract, you may or may not want to make that private as well. In other words, in some use cases, you may want to have a smart contract that everyone can access. For example, in a use case that involved open bidding, where any participant in the network would be able to bid on a particular ask from another network participant. In that case, you definitely would want the smart contract to be open and accessible to all participants. But there are other use cases where the smart contracts themselves might need to be encrypted as well, so that they're not accessible to parties not involved in the invocation of those smart contracts. So what we're showing here in our diagram is that smart contracts can be encrypted. And the reason for encrypting them, again, is because they are stored on the ledger, and by encrypting them with validator keys, we're able to only decrypt them at runtime. So in other words, when the smart contract is actually being invoked, the validating nodes will actually use their keys to decrypt the smart contract as it's stored encrypted in the ledger, and then run them as part of the consensus protocol. And that is how smart contracts can be stored in the public ledger, but can be protected so that they are not publicly accessible.